You remember affine transforms from an earlier lesson. An affine transform is a pixel mapper. It translates coordinates. A pixel headed for one location is mapped to another. In the past, we did that with points and lines and stuff, but if you apply an affine transform to an image, it will map every pixel in it to another location. It's an easy matter to have an affine transform scale and rotate an image for you. And that's just what this lesson is about. I also want to show you all the rendering hints and what they do. We took a quick peek at rendering hints earlier, and I'm sure you're pretty curious about them by now. The example program is in 3 classes. One class is the main line, one is the canvas that displays the image, and the other is a dialog that allows you to set the hints. I think the easiest way to explain this thing is to start with the main line. The main line selects a default image if you don't specify one. Just like in the previous lesson, this one sets up a main window with the canvas object shown at the top and a row of buttons across the bottom. The canvas is named TIC for Transform Image Canvas, and the dialog is named TID for Transform Image Dialog. The Create Canvas method loads the image object and uses it to construct the TIC and returns the TIC to its caller. This method creates a panel object and fills it with buttons. The panel is returned to the caller where it's inserted at the bottom of the window. This method is the one that's called whenever a button is clicked. As you can see, it responds by calling a method in the canvas object to change the affine transform that's going to be used to display the image. And that's all there is to the main line. Now, here's the canvas. Just as was done in the previous lesson, the incoming image is used to construct a buffered image. This is the object that we'll use to construct each variation of the output. The paint method creates an affine transform op object that includes the information of the currently selected affine transform and the current settings in the hint value. Now I've got this so that it's only done if the flag need build is true. That may be overkill, but I know the paint method can be called a lot more often than just when the parameters change. For example, the paint method can be called every time the window is resized or uncovered. And this test prevents the new affine transform from being built every time. It's probably an unnecessary thing to do in this example program, but this is a fairly common procedure in a program that's going into production. This is one of the methods that's called when a button is selected on the main screen. This one creates a new identity transform, which will always bring us back to the original display. The default affine transform is always the identity transform. This method will insert a rotation command into the existing affine transform. Now to do this, it replaces any previous inserted commands. That's the way the rotate method works. It replaces whatever commands have already been installed, so it only rotates. The methods here are called from the mainline window. They set a shear value. I'll show you what that does in just a minute. And they scale the picture. This last method is the one that sets the hints. This method is called from the hint setting dialog. Let me show you that. Now, right here at the top of the class are the declarations for an array of checkbox references capable of holding a checkbox for each selection. There's also a local TIC reference, so we can store the address of the canvas. That will make it possible to call the canvas method to tell it the current hint settings. Each check button has its value defined inside this table. Now, I like tables a lot. They keep me from losing stuff. The constructor builds the window and puts it on display. Now, this method loops through the table and builds a checkbox for each member found in the table. The ones that are indicated as being the default settings are set to true, so they'll show up as being already selected when the dialog pops up. As you will see when the window is displayed, each checkbox is included in a group, so only one member from each group may be selected. That is, they all become radio buttons or toggle switches.